I'll let you kick it off. It looks like we got quite a few people here. Maybe we'll do some quick intros and then get into it.
That sounds great. So welcome everybody. Really excited to have you here with us today. Before we jump in, I wanted to highlight a few items. So as attendees on the webinar today, your camera is going to be turned off and everyone's going to be muted. If you do have questions, we encourage you to use the Q&A tab at the bottom of your Zoom screen where you can enter questions. And we're dedicating a large chunk of time towards the end of today to go through those questions for a Q&A session following the main conversation. And we want to address as many questions as we can, make this as interactive as possible, and talk about the things that you care about. We're also recording this presentation today, and we'll make it available when it's ready in the coming week or so after this to other participants who signed up but were unable to join today. And if you hear or see something from our panelists today that you'd like more information about, feel free to send us an email and we can set up a one-on-one call to discuss more with any of the three of us. And so, let's start by jumping right in with our main topic here today, which is using data to reduce refrigerant leak rates. We're really excited to be having this discussion, this industry discussion. The point of this is not to be an advertisement for Axiom Cloud, but rather to kind of engage the industry in a discussion about how to reduce leak rates. And ultimately, from our perspective, we don't need to spend a whole bunch of money on new sensors or new CapEx equipment. There are ways to drive down refrigerant leak rates using data, using analytics, using automation, which we're really excited about. And we want to talk about, successes we've had and talk with Brian and Kevin about successes, failures, best practices, tips that they've encountered along the way as well. And with this topic really focus being, data to reduce refrigerant leak rates. So with that, let's jump into some quick intros. Kevin Compass is here with us from Climate Pros. Kevin is also the host of the Advanced Refrigeration podcast, which we're very excited to have him with us today, or co-host, I'm sorry. I'm sure your co-host wouldn't be happy about that if I gave you all the credit. And then we also have Brian Gamotis with Grocery Outlet. He's in charge of all repair and maintenance for those 400 or so stores throughout large parts of the United States. And Brian obviously deals with refrigerant leaks, much as he hates to admit it. I'm sure that's as much a problem for Grocery Outlet as it is for other folks. And so he has a lot of war stories from that as well that he'll be sharing with us today. Welcome guys. Thank you so much for participating. We're excited to have you here. So in terms of agenda, I'm going to do less than 1/3 of the talking. Ideally, I want to have you guys do more of the talking. And so that means I'm going to be asking a bunch of questions in these key areas. So we'll start off by talking about why are refrigerant leaks so prevalent? What are the pros and cons of these historical leak detection methods? How can data, analytics, and AI and automation help to detect leaks? Then we can talk through some case studies that we've seen out in the field using data to reduce refrigerant leaks and catch them earlier. And then we'll go into the Q&A. Let's keep going here, Turner. All right, so let's start out by talking about the outsized impact of leaks. So they're really, the key thing that I like to talk about when I talk about refrigerant in a grocery store is that when you're operating a grocery refrigeration system, it's kind of like driving down the highway in your car and the car doesn't have a gas needle. So ultimately, you're going along and everything's fine. And then suddenly you're on the side of the road and you're out of gas. That's at least how, a lot of folks in the industry have historically dealt with refrigerant leaks. There are different ways to approximate how much refrigerant is in the system and when that charge is trending in the wrong direction and declining over time. But it's not a perfect science. And so, with that, there's major maintenance, energy, and sustainability impacts of refrigerant leaks. Obviously, from a maintenance perspective, when refrigerant drops too low, there are uptime issues. So in other words, product gets too warm. There are expensive service calls that need to happen sometimes in the middle of the night. Gas is very, very expensive. Finding leaks is difficult, time consuming, and technician time is really expensive for that. From an energy standpoint, when charge is too low, the refrigeration system consumes much more energy than it needs to. And in some cases, when their charge is too high, there are negative energy and uptime impacts as well. And then from a sustainability perspective, obviously leaking refrigerant is really bad from a scope 2 and a scope 1 perspective. But from a scope 1 perspective, leaking refrigerant, those gases such as R22 or 404 or 407 are thousands of times more potent than CO2 from a greenhouse gas perspective. So leaking 1 pound of that might be the same as driving your car for weeks or months, let alone leaking 2,000 pounds when you dump the entire charge in a grocery store. So Brian, let's start with you here. As an end user, which of these buckets, maintenance, energy, sustainability, is top of mind for you and in the past, and kind of which are gaining importance, which are less important when it comes to refrigerant leaks?
For us, I think it's a combination of the maintenance and the sustainability side. For sure, as the regulations change, seem more rapidly now than they had been in the past. It's a constant flux on the regulation side. That's driving the cost of the refrigerants up really quickly. So we are looking at the cost of it, which is a huge impact, but also on the sustainability side, I mean, you've got a responsibility as an end user of refrigerant to make sure that you're keeping your systems as tight as you can, because it does impact the environment when it leaks. So being able to find that balance between being as leak-free as possible and also keeping the cost down, accomplishing one helps the other. So it really is, those kind of go hand in hand, because if you're limiting your leak rates as much as possible, then you're impacting both of those categories.
And then have you experienced, do you view refrigerant leaks as a uptime risk? It's something that kind of causes refrigeration downtime?
Oh, for sure. I mean, every store is going to be different as far as what systems warm up first. It's just the dynamics of a given store. But when you hit low charge, you're talking, like you said, it could hit in the middle of the night, it could hit during the day, it could hit on a weekend. You never know when it's going to hit. So you're going to have downtime on your cases, and downtime is anything from lost sales to lost product to all the labor that it takes to deal with it at the store level, much less the contractor that I'm paying for. So the downtime on the cases hits in multiple ways.
Yep. Kevin, going to you here, which of these do you think is causing the most pain in the industry today? Is it the downtime impact, the maintenance costs, the energy, or the sustainability related impacts related to leaks?
So for me, it would be the downtime and the maintenance side of it. Coming from a contractor, it would be more damaging that way. I mean, just getting the maintenance down and increasing the maintenance costs is increasing the actual store costs. So the maintenance and the sustainability are big ones. Like Brian said, it is driving up the costs on everything. So the more refrigerant that people are using, the higher the cost is. I mean, the more they keep capping them every year. So, and then the energy also. I mean, everybody's trying to push these stores to be able to save every little penny they can, on every little kW. So I mean, when you are losing refrigerant, you're not going to be accomplishing those energy goals if you're dumping refrigerant in there. And I mean, that money that you're dumping in for refrigerant could be used for, other maintenance things and upgrades and other stuff. So keeping that refrigerant cost down is definitely a plus. I mean, there leaves a lot more money on the table for other upgrades.
Yeah, it makes a lot of sense. And obviously, Kevin is sitting in his truck right now. So Kevin comes to this with a lot of on the ground credibility. And Brian, you were also, in the field working on this stuff just a year ago or 2 years ago at this point. So you also are, super credible when you're talking about this topic. You've dealt with a lot of these issues face to face in the past, if I understand correctly.
Yeah, I was 17 years in supermarkets until my body told me it was time to make a career change. So yeah, I've been about a year and a half now since I've been in the field. But yeah, that's all I did was supermarket work for 17 years.
Yep. So I guess, quick aside here, thinking about that experience out in the field, when you got a call for a leak, what did that look like for you, Brian? Brian and first, and then we can go to Kevin.
Basically, it's just putting, you gotta settle yourself into the fact that you might be there for a while. Is really just being patient. There are times where you're gonna jump, 100 pounds or 200 pounds of gas into a rack, and it actually is a Schrader core. I've had a Schrader core leak so bad that I couldn't even get through the front door with my leak detector. Those are extremely rare. Usually you're in for a good hunt to find the right leak and find where it's coming from. And if all you found on your first leak check was a Schrader core, odds are you didn't actually find the leak. So just walking into a store and knowing that you need to be patient and that you need to be thorough and that you need to keep at it until you find it. And those are the guys that typically actually find your leaks, because they just have that mindset of being patient and being thorough and checking every little place that it could possibly be, even if it means crawling on top of a dirty, dusty walk-in, or wherever you got to go to access the piping.
Unless it's in the concrete and underground or something like that.
Yeah, I mean, there's times where you're not going to find it above ground, and then you're back cutting out lines and pressure testing line sets and things like that when you're pretty sure where you've narrowed it down to. Yeah, so that does happen. A lot of places are going away from underground piping because it is so hard to find those leaks when they do happen, and it's extremely expensive to repair them when they happen. So but yeah, it's just a game of patience. And for me, I always had a routine. I always had a step-by-step leak check kind of process that I went through, where I started in the compressor room and then I went to box tops, and I always did the same thing every time in the same order so that I wouldn't miss anything.
Kevin, does that kind of match up with your approach?
Yeah, almost exactly. I mean, leak checking is 100% almost a state of mind. I mean, if you're not patient and, you're rushing through it. And like one big thing I've always, taught guys is just because you find a decent sized leak, don't stop there. I mean, I don't know how many times I've seen guys, find a pretty good sized leak. It could easily leak 100 pounds in a week or two. And then they miss another giant leak or another decent sized leak. So then they're back there, a month later with another low receiver level or a low refrigerant condition. So I generally, tell guys, don't stop leak checking until you've covered every inch of that store that you can get to. I mean, and then like Brian said, I mean, sometimes you may not find the leak the first time. I mean, that first, go at it. I mean, you may have to come back with a scissor lift and dig into it. But I mean, if you're adding refrigerant to the system, it went somewhere. So, I mean, you need to find out where it went. And the guys that don't give up and, keep diving into it, generally, like, the leak is usually the last place that anybody's going to think to look, on top of a walk-in or, in a space that nobody's going. So, I mean, just getting up there and, going in these places that people don't want to go. I mean, that's generally how you find these leaks that have been, there for a while, that are, hidden on top of walk-ins or in walls, or, just taking your time and, shutting off the equipment. I mean, I generally follow like routine. If I can't find it the first go around, I'll, shut off the rack and let it build up pressure, and then I'll leak check it, let the suction side come up or start throwing things in hot gas defrost if they're in hot gas defrost. I mean, I've seen it where you could barely pick up a leak on a suction line, and then it goes into defrost and it's, spraying out refrigerant. So, I mean, it's really just a state of mind and being patient and checking all the places that nobody wants to check.
Makes total sense. Sounds like a very methodical kind of step-by-step checklist type mindset, and you're probably there for hours, if not the whole day. Is that right?
I mean, it really depends. I mean, some leaks are easy to find. Some days you may walk into a customer that drilled a coil with a forklift, and that leak finds you. Or some days you'll walk into a machine room and something's spraying. I mean, it's easy. And then some days you have a nightmare leak that, I mean, only shows its face when something's in defrost. So, I mean, it all depends. It could be an absolute horrendous day looking for it, or it could be an hour or two you're in and out.
Makes sense. All right, let's go to the next slide, Turner. Basically, right now we're kind of still getting through the part of setting the table here. We're talking about the current state of the industry before we can get into kind of using data. So today, the state of leak detection is obviously the worst case scenario is that you're having case temperature alarms, right? That's where you're already out of gas. You're in a really critical situation. But ideally, folks are not getting there as often today. And instead, they're relying on some of these other detection methods like stationary ppm sensors or sniffers, whether those are traditional or whether they're infrared, manual leak checks, which are typically done monthly or quarterly, depending on the charge of the store and the regulations, or receiver level alarms, where you're, especially if it's not an EnviroGuard with no charge in the receiver, then you can monitor the receiver level using a digital or analog sensor over time, and ultimately determine if the receiver is getting too low as a leading indicator or I guess a slightly lagging indicator for a leak. But given all these various tools in the toolkit today, none of them are that good, honestly. And so it's kind of you have to layer these on top of each other and use them in intelligent ways to ultimately detect leaks before it's too late and before you're running into a really critical situation in the store. And that's because the average leak rate for commercial refrigeration in the United States is still 25%, according to the EPA. And what we've seen at Axiom Cloud in the first 4 months of 2022, we detected leaks at 10% of the stores we serve. We're sold into many stores at this point, over 150 stores. And at the stores where we're actually operating these services related to refrigerant leak detection, we found leaks in 10% of them. And so if you annualize that, that's about 30% of stores leaking per year. So that is, very much in line with what we're seeing here in terms of these numbers, assuming some of those leaks are pretty large, which, statistically they will be. So I guess, Brian, have you experienced, actually, wait a second. Which of these methods have you seen used effectively in the past? What are the pros and cons of each of these various methods? The ppm sensors, manual leak checks, receiver level alarms.
So we use actually all three of these at grocery outlet, and in my years as a tech, most of my customers use at least two of these, two of the three. There's pros and cons with each of them. When it comes to your stationary sensors, whether it's a sample-based, IRLDS system or electronic sensor mounted in a box, there's the maintenance side of it. The mechanical sensors are prone to damage from being bumped and things like that. You'll get a decent number of false alarms from them being bumped or just getting hit and they just quit working. Those ones tend to be a little more sensitive as well to various kinds of floor cleaners in the walk-ins and things like that. So you'll get some false alarms that way. Manual leak checks, it's in my opinion is the best stopgap against leaks. But again, it comes down to training. Some techs are going to be really good at it. Some techs are not going to be very good at it. There's as a former tech, team lead, service manager, I've kind of filled multiple roles over my career. There's definitely techs where if we had a low liquid alarm, I didn't send that guy because I knew he probably wasn't going to find it. So and then receiver level alarms, I mean, especially depending on the type of receiver level indicator you have, is it just an open closed switch that's triggering at like 15 or 20%, or is it an actual analog sensor that allows you to see the refrigerant levels trending down over time? Obviously, I prefer that because every time I was in a store as a tech, I would look at the receiver graph and see whether I was there for a leak or not. I would look at the receiver graph and look to see if everything looks steady or not. So, I mean, you really want to take, we use all three of these modes here at Grocery Outlet, but each one kind of has its pros and cons. There's limitations to each.
One thing I've heard recently related to COVID is they call it the Swiss cheese approach, where you layer on multiple imperfect solutions, trying to catch as many of these as you can. And so it sounds like the PPM sensors are good, but they're not always in the right place. Typically they're only in the machine room or maybe in the return air. And then, they break frequently. The manual leak checks, they only happen every once and again, and it's really dependent. The quality is dependent on that specific tech. Are they in the right mindset? Do they have the skills to actually get it done? And then receiver level alarms are going to be, if it's an EnviroGuard, good luck. And if it's digital, then you only know, once you've kind of reached a really critical point. Am I summarizing that right, Brian?
Yeah, that sounds about right.
And Kevin, on your end, do you feel like there is adequate attention paid to leaks across the industry, or are they generally an afterthought? Kind of second, they're playing second fiddle to other concerns at this point.
It really depends on the customer. I mean, there are customers that drive it home that is their one of their number one things, and there are customers that don't drive it as hard. So I mean, it comes from a customer and a contractor standpoint. I know with us, boots on the ground leak checking, you're never going to beat that in a sense. I mean, the boots on the ground, leak checking is, you're never going to get sniffers in every single spot in the store. So, I mean, boots on the ground leak checking and actually finding leaks that way, to me, is one of the best things. Here at Client Pros, we generally have guys leak check every single time they're in a store. So you're in there for a service call, you change a fan motor, you're done in 10 minutes, you grab your leak detector and you do a quick 15-20 minute leak check. I'm not talking like you go on the top every single box, but you run the racks and you run the cases and check the condensers, make sure nothing's leaking, and just check around the leak detector. I don't know how many times I've been in the store and I found leaks that way, and then prevented refrigerant loss. And then the receiver level gauges are a tremendous help. I'm a big believer of trended data. So generally what I will do, if we have control of that store's EMS, I will, trend out the receiver level for in a complete year. It may only be 5 to 7 minutes, but it'll be looking at it every 5 to 7 minutes for an entire year. And then guys, when they go to the store, they could look at that graph, pull it up, and they could see, do we have a small trend down? I mean, looking at a trend for a year, you could easily see a leak that's, depending on the store size, where you're losing 30 to 50 pounds a year. You could easily show up where it wouldn't show up on a 2-week graph. You're never going to see that. But on a year graph, you could see that. Obviously, you're limited with digital switches. I mean, it kind of is what it is. It's either an alarm or not an alarm. You try to get there before the digital switch hits. But I mean, with that sense, I mean, the cost of EMS components and adding these analog gauges in have dropped tremendously. So I mean, in my eyes, there's no reason not to have an analog receiver level gauge if you are concerned about refrigerant usage. And then the the leak detectors, the stationary leak detectors, they do work. I think a lot of times the end user puts them in a bad spot. It seems like every single end user puts them right by the door in the corner of a box, and they usually get annihilated by carts and forklifts and pallets. I think if they started putting them up higher, there would be a lot less nuisance calls. I know that they say the refrigerant's going to settle on the floor because it's heavier, but I mean, putting them up a little bit higher would prevent them from failing so much, I think. I mean, in a machine room, they're great though. I mean, they generally will, depending on where it's at, as long as it isn't right next to an exhaust fan, will usually pick up a leak pretty well.
Makes total sense. Yeah, it's really interesting about the receiver level alarms and how, or if you're trending that data, we're already getting into the data conversation here, and how valuable that can be basically to identify otherwise invisible trends over the course of a year. And you can kind of visually filter out the variations from other factors like condenser split, like heat reclaim, et cetera. Over the course of that year. Cool. One other closing thought here. So I actually got permission from Tom Matthews over at Baseline to quote him. We had a great conversation with him about this, but he was unable to join us today as a panelist. But what he said was, the facts tell us there are supermarkets that are free of leaks and go for years without any replenishment. Then there are stores that open as leakers and never stop leaking. And then there's a large group of stores somewhere in the middle. So spending leak checking hours in stores with a refrigeration system that's not leaking is insane and a terrible waste of resources. And so, the message that Tom is sending us is basically, there's a huge opportunity here to apply those resources, those technician time resources, to stores that need it the most, rather than kind of taking a sledgehammer approach and sending folks out to do leak checks at every single store, even the really high performing ones. I thought that was a really interesting, nuanced point. So let's keep going to the next slide here. So what has changed in recent years? So one is the 2019 AIM Act authorized the EPA to regulate 20 HFCs and will lead to a 15-year phase down period across all industries. Obviously, then there's the labor issue. So Brian, how have the labor shortages, in-house employees and technicians, impacted how you think about refrigerant and leak detection?
Well, it hasn't changed our approach. We still want those boots on the ground. What has really changed is that I have to have a little more patience to give my contractors time to get there and to do those leak checks. It really does. It does impact us because the techs are feeling pressured to get to the next call, especially in the summer. So sometimes those where that one service call would go from a 10-minute fan motor to, a half an hour, 45-minute call because they're going to go ahead and do a leak check, that stuff starts to not happen as much. So it does impact us at the end user level in that regard. Our approach hasn't changed, but just the sheer time, the time that it takes to do that, and the lack of available man hours from the contractors means that at least in the summer, that happens less and less. So just making sure we have to make sure that we're extra thorough on the quarterly PMs that we do, and that we're extra thorough when we do have the time, so that we're catching as much of it as we can.
So my sense is that technicians are so overworked at this point that they're constantly making trade-offs in their mind about how do I get this food cold and get out of the store as fast as I possibly can. And so that there's no incentive to think about, hey, how can I tune up the store to reduce its energy bills, or how can I catch a refrigerant leak. It's more about like, is the food cold right now? All right, let's get out of here as fast as I can and deal with the other 6 service calls on my plate today. That's my sense about the industry right now. I'd love to hear your thoughts on that. But basically, to me, what that implies is that there's going to be fewer leak checks, and it's going to be tougher for those folks to get into that mindset that Kevin was talking about, of like, really, really methodical, taking your time, and having a high quality leak checking approach. I guess, Kevin, does that stuff resonate with you that I just said, or am I getting something wrong there?
I mean, that's 100% honest. I mean, you try to do your best with, your time management skills and try to, triage as much as you can. But, when it's 100 degrees outside and, half the stores you have are down, or there's condensers popping off everywhere for, high pressure issues. And I mean, yeah, that 10-minute fan motor you got is 10 minutes in and out. And yeah, that leak check, I mean, when it's 100 degrees outside, it's probably not going to get done. I mean, we try to get it done, but at the end of the day, there's only so many hours a guy can work. I mean, you can't just keep pounding more work onto guys. I mean, there's a serious labor shortage in this trade, and it's only getting worse. So, I mean, in the summertime, it more so turns into a triage situation than a, trying to prevent every little leak.
So how do I keep the wheels on the bus right now rather than thinking about, what's good in the long term?
Yeah, I mean, obviously in the wintertime and the fall and spring, it's a lot different. But in the summertime, I mean, coming from a contractor set point or mindset, I mean, it's almost impossible to do that with the amount of labor we have.
So that brings us to the topic of data. Obviously, there's an enormous amount of data in these grocery stores, kind of in the controllers today, whether that's a E2 on site or a microthermal controller or a Danfoss controller. And Kevin, you said something yesterday which I thought was really kind of cool, which is what are your thoughts on using data and data analysis, data analytics to address this challenge?
I mean, I think it's a great thing. I mean, it's one more tool in the technician's pocket. When you get a customer that has a leak alarm or something going on like that, and you already know that I'm going to send a guy there. He's got a trended receiver. He's got, he could, use these tools that he has in his pocket, to see if it actually is a refrigerant leak. I mean, I live in Chicago area. So, I mean, we go from today it's 100 degrees. We're way above design. And in the wintertime, it was getting down to minus 30 last year. So, I mean, you're going from 100 degrees to minus 30. That's a huge design challenge that, I mean, no matter how well you engineer something, you cannot make something that's going to run awesome at 100 degrees and then amazing at minus 30. It's not going to happen. So, I mean, you're going to have times where you log some refrigerant on the roof. So, I mean, is it actually low on refrigerant, or, I mean, is it logging on the roof? I mean, that's where the data analytics comes in. Are we actually losing refrigerant? I mean, can we look at the graphs and pull them? Or, I mean, or I just go into split and I just didn't pump out fast enough. I have a big 12 fan condenser and I just didn't pump out fast enough. Well, I mean, using that data and that analytics, I mean, you could, essentially assign a, lower level guy that give him that tool. He's get a little more insight to the system, or a service manager or a lead tech could look at that and say, okay, yeah, you got a leak over here, or this store looks like maybe a little bit low on refrigerant, but looks like we're logging gas in the condenser. So I mean, that side of it would be extremely helpful for guys to actually see that data and that trended over time. And I think it would help prevent a lot of issues, a lot of overcharging, a lot of guys undercharging stuff. I mean, it would prevent a lot of calls and a lot of leaks before they happen. I mean, I'm a big fan of like up here, so we split a condenser. I mean, we may have to run in the wintertime a 45 to 50% receiver level to have enough gas for when we on split. We're 15 to 30% depending on the customer. So I mean, if you have a 10% alarm set point in your controller and you have 50% sitting in that receiver, and then all winter long you've been leaking 50 pounds a month, when you go to on split, now you're 200-300 pounds low on gas, but you didn't alarm till 10%. So I'm a big fan of moving that alarm threshold up when we're in split to try to save some of that gas. And that's where that analytics and tuning comes in, where you could actually move those make a floating set point where it's constantly moving instead of one fixed alarm set point where you've already lost all your gas.
Yeah, you hit on some really important things there. Yeah, I guess kind of zooming out a little bit here. If we think about the state of the industry today and all the other surrounding industries and similar verticals here, compute power has gotten really, really cheap. And there's in grocery stores today, there's already so much data from hundreds to thousands of existing sensors. So, every valve position, every compressor status, every pressure, every temperature, condenser fan status, everything in the whole store. And so all that data tells a really, really powerful story if you can essentially process it in a way that enables you to see what's happening and run analytics and ultimately kind of predict what will happen in the future. So at Axiom, we use what we call a digital twin model. One really key piece here is that no single sensor tells the whole story. And Kevin was talking about having to set these essentially thresholds or threshold alarms are a really, really blunt instrument. They're just not they're not great for situations like this where you have massive fluctuations because of things like condenser split, domestic hot water heat reclaim, or air handler heat reclaim, or massive swings in outdoor air temperature, where it's very natural to have large variations in receiver level, for example. And so if you're setting a specific threshold, then you have to basically decide, do I want to have a bunch of nuisance alarms and be really tightly managed here, or do I want to reduce the number of nuisance alarms that my store managers are seeing, and only alarm when it's really critical? And I think a lot of folks in the space tend towards the latter there, basically fewer nuisance alarms. So that's why no single sensor telling the whole story is so key here, and no single threshold alarm is really something that it's not a good strategy ultimately to help avoid a lot of leaks unless they're the big catastrophic ones. Brian, do you have any reactions to the stuff that I just said? Does this kind of match your experience?
For sure, I'm with Kevin in the thought and the way I look at the data and the analytics. It's to be able to use the controllers that we have and all the extra sensors that you've got to be able to catch the stuff sooner when possible is, I mean, you've got it there. Like, why wouldn't you use it? If you can catch a leak before you're, like, the split is the perfect example of the systems that go. I mean, every spring as a tech, you ended up with a steady stream of service calls for low liquid for all those systems that sat in split condenser all winter long with a leak. And then they come out of split in the spring and all of a sudden they don't have enough gas in them. So, and you're dumping, I had customers with some pretty good size racks. So I was dumping, every spring I'd have service calls for a handful of stores where we'd go find leaks and then dump, 300-400 pounds of gas in. That's a lot of juice and a lot of coin. So to not take advantage of the ability to do some of this, using other sensors and combining the data to get better refrigerant tracking on your levels it'd be crazy not to.
Yeah, one other question that is going a little bit off script here. When you guys are thinking about leaks and the biggest contributors to leaks that you've seen out at grocery stores, what do you think the percentage of really big leaks are versus the slower leaks that are tougher to detect?
I mean, for me, it really just depends on the store. I mean, there's some stores where, huge leaks are common. I mean, the older the rack, I mean, the more stressed out all the piping is. I mean, big leaks seem to happen more the older it gets. I mean, the smaller leaks come in, like I've seen a lot of new stuff where there's case controllers everywhere and there's 200, 300 plus transistors. I start to see smaller leaks in those, a packed angle valve leak in here, another packed angle valve leak in there, a transistor leak in here. It really just depends on the store setup. I mean, it's probably, 60% bigger leaks and the rest are smaller leaks for me. I mean, I see a lot more blowouts than I do smaller stuff here lately, as lately as it seems, especially with the summertime. In the wintertime, you get a lot more slower leaks. In the summertime, everything's running higher pressure, more stressed out, running hotter. You're burning up clamps more on discharge lines, and you get discharge line rub outs like a lot more.
Makes sense. Yeah, I mean, my perception and what we've seen in the field is that data analytics are not going to be super helpful with the big blowouts. Ultimately, if you have a 1-inch hole in the side of your refrigeration, there's not much. It doesn't matter if you detect it right when it happens, because by the time the tech gets there, it's going to be empty anyway. So it's going to be more helpful with those slower types of leaks that are tougher to detect over the course of that would ultimately result in a low gas situation over the course of 30 to 180 days, for example. And so at Axiom, we figured out ways to basically detect those leaks in a time period of around 3 to 7 days. That's been our target. We've been consistently achieving that versus waiting for that 30 to 180 days, which is often when those low refrigerant levels are ultimately detected by the threshold alarms. I guess, Brian, have you guys used some other data analytics solutions in the past, or have you seen some solutions being used successfully in the past to help address these sorts of issues?
We are still, we're still trying to get, we still have a lot of systems that, a lot of stores that have single systems, so we don't necessarily have the ability to track the refrigerant levels in the individual singles. And the data analytics side is kind of it's a relatively new concept of how to look at refrigerant leak detection. So we're just starting to move that direction as far as looking at more than just a liquid level switch or a liquid level analog gauge. So I'm excited to see what it can do for us and to improve our leak rate even more than it already is. But we haven't done a wide rollout of this type of leak detection yet.
Makes sense. Cool. Obviously, there's been a lot of attempts to do this over time. I guess given where we are in today's discussion, let's go straight to case studies here and talk about a couple different examples, Turner. We might have to skip over a little bit of the agenda just to make sure that we have time for Q&A. So, here's one case study. This is actually a leak that was detected at a grocery store earlier this year, it looks like, in January of this year. And ultimately, the way that at Axiom, the way we're detecting leaks is we're looking at primarily the receiver level, whether that's digital or analog, and then we're combining that with enthalpy in and enthalpy out at the condenser, because those are the two places where refrigerant is pooling up the most, where you're going to find the most mass of refrigerant at any given time. And so by estimating the amount of refrigerant in both of those two locations, that gives us the ability to then detect trends relatively quickly. And then we're able to normalize for all these other factors that are causing big variations. Again, the really common ones being various types of heat reclaim, condenser split, outdoor air temperature, and a few others as well. Ultimately, the output of one of these, when we're detecting a leak, we can't go to a technician and say, hey, look at this, really cool digital twin AI-based analysis we've done. Instead, we have to put this into a form that's really digestible by a technician. And so that's what we've done here. This is an actual anomaly notification that was sent to a technician and ultimately resulted in a confirmed leak and a repair over the time period of about 4 or 5 days. And this is a leak that would have ultimately resulted in a bad situation for that grocery store had it gone undetected. And there were no threshold alarms when this was sent out. So ultimately, what we've done here is we try to make this super simple for the technician by showing only two different data streams that tell us the story of the issue here and makes it readily apparent to anyone looking at this. The receiver level over time, which is the green line, and then the orange line, which is the outdoor ambient temperature. So basically showing a downward trend in receiver level while the outdoor temperature remains somewhat constant on a day-to-day basis, ignoring those diurnal variations. And so ultimately, again, this did result in the confirmation of a leak, repair of a leak, refilled gas, fixed the leak, and avoided a big problem. Let's go to the next one here. So this is another example here of basically, actually, Turner, do you want to talk about this one? I'm not quite as smart on this one.
Yeah, this one's pretty similar. It's just kind of another example of the same thing, but with a receiver that is not full all the time. So rather than just looking at receiver level trends, this was, I believe, in a ViroGuard system where, receiver is empty most of the time, but you can still see day to day kind of the amount of time the receiver was empty each day is decreasing, which was also indicative of a leak on this one.
I'm remembering this one now. And on this particular store, there was not a analog sensor. This is a digital sensor. And so, that kind of reduces the quality of that data coming out of that receiver even further. So it's really, really tough to see if you're just looking manually at the data. That's where the digital twin modeling can become really, really helpful. Is by, correlating what's happening in the receiver and that, relatively coarse data stream with what's also happening in the condenser, using temperature, pressure in, temperature, pressure out, and drop leg temperatures, things like that. And so again, this was a confirmed leak that was detected on the time frame of about 6 days, and ultimately did result in a confirmed leak, in a repair, and a refill, and an avoided outage. And so this is our third and final example. Turner, you want to talk about this one?
Yeah, sure. So this was just an example showing that although without any receiver level data, it's quite a bit harder to detect leaks just with data. It is possible. So this was a store where there is no receiver level data coming in, but we were able to detect a leak just by looking at variations in subcooling on 2 of the racks in the store. So the green trace here, you can see that the subcooling is pretty consistent over time, whereas the yellow condenser, which was condenser C, subcooling is fluctuating. It actually turns out with, like we talked about before, condenser split. So this was just kind of indicating that when the condenser goes in and out of split, this big change in subcooling was telling us that there was a low charge here.
And so again, a leading indicator for for downtime, essentially, and for warm case temperatures. So, and again, the cool thing here is that, this is where the digital twin model is able to detect a refrigerant leak without a receiver level sensor at all. And this one was also confirmed. There was a leak confirmed by a technician. It was repaired, it was refilled, and that catastrophe was avoided. So yeah, thanks, Turner. And as folks on the line have questions, please enter those into the Q&A section of Zoom, and we'd love to address those questions. One other thought here from Tom Matthews at Baseline that I wanted to bring up. There's another quote that he sent over. He said, "I've been watching attempts to conquer this challenge for many years. There have been schemes that put load sensors under receivers to track the charge weight, schemes that watched receiver levels using cameras, schemes that watch for flash gas with optical sensors, and even float switches. All have failed." And then he said, "Based on our own testing and development work, I'm sure that an AI-based solution is relatively close at hand, as long as someone has the resources and the data and the expertise to make it happen." So, Tom is a big believer in using data to ultimately help to detect leaks faster and earlier and more intelligently. And yeah, we were sad he couldn't join us today, but thankful that he was able to provide some of these quotes for us to talk about. So with that, Turner, let's jump into Q&A.
Yeah, so we've got a few good ones already. I'll feed them to you guys. First one that we have here is, what kind of sensors / data does a business need to have in place in order to allow analytics around leakage?
I guess I have an answer to this, but I want to make sure that, Brian, do you have any thoughts on this topic?
I think your big 2 are going to be outdoor ambient, and then also receiver level tracking of some sort, preferably analog. But if you can't do an analog on a given receiver for whatever reason, then a digital switch. So with those 2 items, you really can track your receiver level along with your outdoor temps and see if it's apples to apples. Maybe you've got maybe you've got a 15% receiver today, and yesterday you had a 20%, but it was also 80 degrees yesterday and today it's 50. So being able to look at that data over time and see that, okay, on a given day when it's 50 degrees out, I'm consistently at 15% every time. So that 15% is not a worry to me today. It's those are probably the two biggest sensors that you'd want to have, in my opinion.
Kevin, what are your thoughts here?
So an analog receiver gauge and or like a Hansen probe for rod and outside air temperature. And another big one for me would be drop leg temperature. You could with those and drop leg pressure, you could do a lot of remote troubleshooting and trending. You could see if you're actually logging gas that way, if you have super high subcooling, if you're logging gas, or if you're drop legs smoking hot, you have an issue with your condenser. That's why you're not making as much liquid. You could trend a lot more with those 4 sensors than just having outside air or just receiver level, but definitely receiver level. I mean, a digital switch, I think that whole era should be dead now. I mean, analog gauges have come down, so much in price that, I think that, not installing it is just a huge waste of money, energy, and time.
And Kevin, one thing you mentioned to me, I don't know if I misheard here, but it's possible now to install an analog sensor without pumping down the system. Is that right?
Yeah. So, if you have like a Hill Phoenix rack or, most of the time I see them on Hill Phoenix racks, like for example, Walmart, they're installing analog receiver gauges on every single one of their stores. So all we're doing is taking they have a senior and a junior gauge. A junior gauge is usually what you see already installed with the level sensor. Now they have them, Rochester makes them for senior gauges, and all you do is take the gauge face off. If you already have that 0 to 100% level, take that gauge face off. You slap on the new gauge face, and now you have a 3-wire Hall-effect receiver level gauge. So now you're
so
able
the probe
to
is already
that.
in the vessel, but you're just changing out the
Yep.
telemetry. Got it.
Correct. That's only on a laydown receiver. On a stand-up, you're going to have to use a Hansen probe. So you're not going to get around that. You're going to have to do a pump down there. But on the laydowns, the majority of what I see anymore has been laydowns. So you have a huge ability to pick up that data and now prevent leaks with it.
Yep. Yeah. It's so interesting to hear the sensors you guys are saying. It exactly aligns with my thoughts here. Basically, receiver level, analog's better, digital is not as good. Outdoor air temperature, the really cool thing there is that you don't actually need that sensor on site. You can get that from hyperlocal weather services really easily. And it's good enough typically. And in many cases, also the outdoor temperature sensors on roofs we found are super unreliable because they get hit by the sun or they're under the condenser, and depending on the condenser mode, et cetera, they're providing weird data. And then the ones that Kevin was mentioning around subcool at the condenser or drop leg pressure and temperature, that's I guess I was saying it in a slightly different way, but ultimately that comes back to enthalpy in, enthalpy out of the condenser. So we're saying really the same thing there. Which is great to hear. The other thing that I want to add here is that even if you as an end user don't have all those sensors available today, there's still ways to enable this. And basically that involves using data analytics and modeling to create essentially virtual sensors. And the idea here is you have all kinds of data kind of around a specific sensor or where that should be, and you can use that to approximate what that sensor would be reading if it actually existed. And so, that's again where data can become really, really powerful, is helping to kind of make these sensors appear out of thin air, even if you don't already have them, if you have surrounding sensors that are providing other relevant data streams nearby. So let's jump to the next question, Turner.
Yep. Okay, so here's another one. We got a question about kind of CARB requirements in California. So this person is saying that in California, all stores have to have some sort of leak detection, or they have to do manual leak checks every 30 or 90 days, depending on the system size. Does having a system like that change those requirements at all? Or do you still have to have other leak detection methods?
Yeah, great question for whoever brought that up. Thank you. Basically, if you're a big store in California with over some number of pounds of refrigerant, you got to do a manual leak check every 30 days, just it's required. Otherwise, you got to do it every 90 days if you're a smaller grocery store with fewer pounds of refrigerant. However, if you have a leak detection solution from Axiom or from Bacharach or whoever else, you can eliminate those manual leak checks, and that can be really a huge cost saver and ultimately drive better outcomes in many cases. If rather than just relying on the manual leak check, again, it comes back to kind of the Swiss cheese methodology, where you're layering on various things here to help catch more and more leaks. But ultimately, that is what a lot of Axiom customers are doing. Is on the CARB website, there's a drop-down menu of acceptable solutions, and Axiom Cloud is listed there, and as are many others. And ultimately, these are tools that can be used to help avoid the requirement for those manual leak checks. Doesn't mean you should stop doing manual leak checks when someone's on site. Absolutely not. But ultimately, you don't need to spend a whole bunch of money just to have someone go out there and do it on a store that is performing perfectly well, and instead focus your resources on the stores that need it the most, where we know there's issues, where where ultimately there's been leaks and we know it's a leaky store. Going back to Tom's feedback. Maybe one last question, Turner.
Yeah, here's an interesting one. Maybe for Brian or Kevin. Have folks had any experience of an odorant being added to a refrigerant system, like they do with natural gas? Just thought that was interesting.
I mean, I've never heard of that, but I mean, refrigerant does have a smell to it. I mean, a large quantity of it does have a smell, but I mean, you're not gonna pick up generally unless it's a huge quantity, that smell. Maybe in a machine room, you could get a hint of it, but like, you're not going to pick that up. I mean, that's what the leak detector's for. I mean, it's picking up minute ppm of refrigerant, whereas I mean, our nose isn't going to pick that up.
Makes sense.
Yep. Yeah, we've got a few more good questions, and we can follow up offline with some of these people if you'd like. And some people submitted them anonymously, but we should probably wrap up here.
Maybe last question.
Sure. We've got one really technical one that's probably too long. I guess quick one. How can you measure that the leak was, in quotes, detected within 3 to 7 days with data? Yeah,
good question. So that once we've detected a leak, at least with the Axiom solution, once we've detected something, then that's kind of the red flag. And at that point, we can go and what the software is doing is it's not only detecting and saying, look, here's a problem. It's able to go back and estimate, when did this problem really start? And that's again by looking at these trends. So if things are going along in steady state for days or months or years, and then suddenly there's a change in that trajectory, that the data in which that change occurred is typically the start of that problem. So if you're going along like this and then suddenly you see a dip, when that dip occurs, that's when the problem starts. So that's how we're able to say, hey, this problem started 3 to 7 days ago, and that's our target basically, and we are consistently achieving that target across the fleet today. So we are out of time. It's 10 a.m. Pacific. Thanks everyone so much for participating in today's discussion. It's been a really, really great one, and yeah, we're so happy that folks in the industry are participating in this conversation. If just one person goes back and catches one leak, I will consider this a big success. And if folks are kind of changing their practices and thinking about leaks differently and lowering refrigerant leaks rates, that's going to be huge for their bottom line, but also for this industry and for the climate, which is really, really motivating for me. So, and for the Axiom team, and I think for everyone on this call. So thank you so much for participating, and keep up the good work with leaks, and let's kind of push this industry forward together. So thanks all.